Hi everyone. Now we are going to discuss about closest pair problem. In this presentation, we will understand what the closest pair problem is, learn the brute force algorithm used to solve it, discuss on optimization to improve efficiency, and finally analyze its computational cost. So in this presentation, we will cover three topics: introduction to the closest pair problem, the brute force algorithm used to solve it, implementation concepts and performance analysis. Let's begin by understanding the problem. So the closest pair problem is well-known problem in computational geometry. The objective is to find the 2 points that are closest to each other from a given set of n points. Each point is represented using Cartesian coordinates such as x and y values. To calculate the distance between 2 points, we use the Euclidean distance formula. So distance equals the square root of this quantity. So x1 minus x2 to the whole square plus y1 minus y to the whole square. The algorithm compares the distance between every possible pair of points and identify the smallest distance. Now let us understand the brute force algorithm. Initially, we assume the minimum distance represented by d as infinity. Next, we use two nested loops. The outer loop selects one point, the inner loop compares it with every remaining point. For every pair of points, we can calculate the Euclidean distance. If the calculated distance is smaller than the current minimum distance, we update the value of d. After all comparisons are completed, the algorithm returns the smallest distance found. Although this approach is simple and easy to implement, it compares every possible pair of points. Computing the square root repeatedly inside the loops increases computation time. Fortunately, we can avoid calculating the square root during comparisons. Instead of comparing the actual distances, we compare only the squared distances. Since the square root function is monotonic, the smallest square distance also corresponds to the smallest actual distance. Therefore, we compare x1 minus x2 to the whole square plus y1 minus y to the whole square. So this optimization makes the algorithm faster while producing the same result. So the basic operation analysis, let us now analyze the algorithm. The main operation performed is squaring the coordinate differences. Since every point is compared with every other point exactly once, the number of comparison is n multiplied by n minus 1 divided by 2. Therefore, the time complexity of the brute force algorithm is big O of n square. So the space complexity is big O of 1 because only a few variables are required. Thank you.